We are working on the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. Previously, we used basic turtle commands to create a game board of this sort. This had like a blue background and then 42 squares arranged in 6 rows and 7 columns. Now, in order for the game to proceed, we need to know the state of each of these circles. What I mean by state is, well, is the circle empty? Does the circle have a player coin, or does the circle have, let's say, a computer coin? So really, each circle can have three possibilities: empty, player coin, or computer coin. We need to know this. And in order to do this, we will create a list of lists. Now, I'm going to talk about this in some detail. Basically, we will have a list of lists which will keep track of the state of this board. Now, what do I mean by this? Essentially, the idea is that I will view, let's say, the first row as a list, and I will put that, let's say as list 0. It will have 7 items because 0 until 6. Likewise, the second row, third row, and so on and so forth. So I'll get 6 lists corresponding to the 6 rows, and then I'll put them all inside a mega list. That's why I call them list of lists, so that the entire board is represented through this two-dimensional structure. Now, at this point, you might wonder, why am I doing this? Am I overly complicating things? Why couldn't I just say, okay, look, I'll store all the items in a single list, let's say 0 to 6, then, let's say the second row, the third row, and so on. But it turns out that the indexing becomes a lot more logical once I have list of lists. And that's, in fact, like I told you, one of the major learning goals from this activity. Each of these items will have 3 values. If the circle is empty, we will make the value 0. If the circle is, let's say, red, the player coin, we'll make it 1. If the circle is blue, we will make it, let's say, a 2, which is basically the computer coin. Now, just as a sort of side thought, we are creating these lists as integers. But in case you're working with a very memory constrained system, you can even think of doing this at a bitwise level, in which case the entire representation becomes much more compact. But that's, of course, not needed, right? It turns out that we have to be somewhat careful while creating a list of lists like this. Uh, the main idea is that once we create it the way we want it to, we would want each and every item of this to be individually accessible. If we are not careful about how we are creating it, that property goes away and the entire value of this thing completely collapses. So the way we will do it is that first, let's look at an incorrect way of doing this list. See the problem that comes up and then see how the right way would be, and how it solves the problem that we are looking at. Later on, we'll have a more longer discussion on this whole concept of shallow copy, which is what causes the problem. Remember, the whole idea is that we want to create, let's say, a list of lists. So I start with an empty list. I just go and say board is, for example, let's say empty. And I already have n calls and n rows defined. So I just go and say row is, for example, 0 times, let's say, n calls, right? So n calls, because I want that many columns to be around. So that's one row. Now I just write a for loop. I just go and say for, let's say, in range, say n rows, and I just go and say, well, board dot append, for example, the row. Now this sounds very, very logical. In fact, let's run this code. When we run this code and I look at board, it does look like I've created, let's say, a list of lists. Notice the board itself is a list. So if I look at type of, say, board, that is a list. Type of board 0 is also a list. That's because you can see clearly square brackets, and inside all items also have square bracket. The problem, however, is that when I try to, let's say, access any one item, so I just go and say, well, please update, for example, board, say 1 and 1. Now, what I mean to do really is that, so what I want to do really is that I want to index the item 1 of board 1. Remember, board 1 itself is a list. So I'm really looking at this particular item. Let's say I set it to, say, 100 just for illustration. Now the problem is when I look at the board, right, you notice that in all the rows, unfortunately, it has become 100. Now this is really confusing. This is really somewhat strange for those who are coming to Python newly, because why did this happen? I went and explicitly changed, for example, item 1 of board, which was a list, and item 1 of that list, I made it 100, but everything became 100. Let's try it once again. Let's say I went and did, for example, board maybe 3, so board 3, let's say 2. So basically what am I saying? I'm saying look at item number 3 of board, which is 0, 1, 2, 3. So that's the fourth list, and item 2 of that list. So that is basically the third item of, let's say, this list. If I, let's say, made it say 200, and I look at board now, you realize that in fact somehow every row, the third item has become 200. Now this is clearly a problem. This is happening because what is called shallow copy. Now we will have a separate discussion about shallow copy later on, but let's see how we can fix this problem. What is the right way of creating a two-dimensional list? So the whole idea is that instead of creating just one row over here and appending it again and again, which causes this problem that I just saw, we will instead create all the rows explicitly, and and that will basically solve the problem. So let's just see this here. I will comment this out because that's not the right way of doing it. There are actually a few ways, let's say, to get it correct. So I will just go and say, well, let's say for, say in range, say n rows. So what I'm saying is that, well, for every row, create a list, which is, let's say, an empty list. Now go and update this list again explicitly. So I say for in range, for example, n calls, I want to go and append a 0 to this. Now see, the difference here is I am creating that entire row completely in this for loop. That row has been created, let's say, sort of explicitly. And I'm then going to say, well, board dot say append say row. So the row was created. So the point is that every time the loop runs, for every row, this list called row is getting created newly, and hence it's not a, let's say, a copy of the previous one. When I do this, in fact, when I, let's say, run this piece of code now, so if I look at board, well, but if I were to do exactly what I was doing earlier, board 320, now when I look at board, you notice only this particular item has become 200. Everything else is still 0. That's why this is a correct way. We can do it slightly differently as well, somewhat differently. It's almost the same actually. What we can say is that, look, let me just take this for loop and rewrite it somewhat, let's say, differently here. I can go and say, look, for kk in range, for say kk in range n rows, so do almost exactly that. Say board dot say append list. So I'm appending an empty list to the board, and thereafter I am, let's say, on that particular list, let's say board say kk, I go and append that many zeros. So that will also do my job. Let's convince ourselves. Again, the whole idea is that I'm not taking one row and copying it over and over again. In fact, I'm creating every row explicitly. That's what's happening here. I'm creating an empty list for that row and then populating that, let's say, that row item by item, right? So when I see this, let's again test that this works. So when I, let's say, run this again, board looks okay, but the test is really this. When I look at board, notice only one row has been changed, which is what I wanted. Unlike earlier where all the rows were really changed. Now, all of this, remember, whenever we have a for loop, there's a possibility to write it more concisely as a list comprehension, and that's what I'm going to do. So I'm going to also comment this out. We will stick with the code that I will now write, which is to say, okay, look, I don't even need to initialize the board here. I will just write in a single statement list comprehension in 2 dimensions essentially. So I'm going to say 0 for, let's say, underscore in range, say n calls, and say for underscore in range, say n rows. Now, if you think about it, really what we're doing is something like this, or even something like this. Basically, we are running 2 for loops through a list comprehension in a list comprehension, and this is explicitly creating every row. Once I do this also works. So board is now all zeros. Now the test is this indeed. When I do this, notice only one item has been changed. So I have the capability to, address every item of this list in an independent manner. And that's absolutely vital, because otherwise the whole game will collapse. say so the so here is the summary of the methods that I've used. Basically, I finally used just this command, but you should understand that this is basically a sort of compressed version of these for loops. You could use any of these. Like I said, the important point is that each of those items must be independently accessible. This is something we were looking here. So notice when I'm changing, for example, 05, I make it to only this changes. Uh, we will, however, discuss this in a lot more detail. Like I said, we will look at an incorrect way of creating this. In fact, we already saw this, because this will bring us face to face with a very, very important concept of shallow versus deep copy in Python. This is important in Python, very, very, very important Python. In fact, not only will we see it in lists, we'll see this in other structures as well. So that's for a separate video. Before moving forward, however, I will just write a function so that it becomes easier for me to display the board. Remember, notice when I'm writing it like this, it's kind of hard to see what's going on. What I will do is that I will just create a function here called, say, so say, say def display, uh, say board. Now what I want to do really is that in this I just want to display the contents of the board. So I just say for kk in range, let's say n rows, not sorry, n rows, I want to say print board, say kk. Now this makes it much more easier to appreciate what's going on. So when I, let's say, run this piece of code, so again I come in here, notice the board has not changed. It looks a bit like all over the place, but when I see it this way, it is nice. And the good thing is, now if I were to say draw the board, I can see a perfect correspondence between the circles here and the numbers over here. In fact, we can do our, let's say, the test that we just did. If I set board certain item to 200 and I again display board, you can see very clearly that this item has become 200. Everything else is unchanged. I hope you found this interesting. This is a very important concept. As always, our way of learning is by building activities, because that is so much more fun. Look at our website www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Enjoy programming.